In the preceding video we have discussed the condensation reaction of an amine with a carbonyl compound giving rise to an imine and water as the condensation product, condensation byproduct. Typically this reaction is catalyzed by an acid, so a proton, and a counteranion, a minus. In the preceding video we have discussed how this carbonyl group is activated by the acid catalyst, and it was clear that the acid catalyst will preferentially protonate this amine, giving rise to such an ammonium salt, and this ammonium salt then might coordinate via a hydrogen bridging bond to the carbonyl group, as an effect increasing the electrophilicity of that carbon here. However, this reaction can also take place without adding a special acid. So it seems to work without an acid catalyst, and for these cases you every now and then find such intermediates, zwitterionic intermediates, with an anionic charge at the oxygen, an alcoholate, and an ammonium group here. Wow! These zwitterionic intermediates are on a rather high energy level, since, well, the charges are separated. Well, and actually I don't believe in intermediates like that, especially since one can discuss possibilities for formulating, writing down a mechanism without being forced to have these zwitterionic intermediates. Well, first of all, let's have a look at what happens with an amine and an acid, for instance acetic acid. Well, an acid of medium strength, pKa 4.7. Well, it will instantaneously protonate that amine. That means we have an equilibrium of the free acid and the amine and an ammonium acetate. Well, and the equilibrium is by far on the side of that ammonium acetate, since here we have a pKa of 4.7, here a pKa of 10.5. It is a weak acid compared to acetic acid, but the acetate will be generally still coordinate in close proximity to the cationic charge via a hydrogen bridging bond. Well, we shouldn't forget that usually these reactions are not done under dry conditions. Well, we have present always some water. Some water is formed during the condensation reaction, and also the ketone and the amine are not usually not added under completely dry conditions. A little bit of water will be still present. So that means also water should be there. Water also is an acidic compound, but also a very weak acid with a pKa of 15.7. In equilibrium, a coordination will take place, so to the amine there will be water coordinated via a hydrogen bridging bond, and every now and then a short-lived intermediate, an ammonium hydroxide, will be formed then. Well, only a slight movement of that proton towards the nitrogen is necessary to form that. So it will be formed every now and then and will, very soon react into the other direction again. However, we will have present in our reaction flask not only the amine and the carbonyl, but also some water and these association via a hydrogen bridging bonds. And it is a good idea to assume that all those reactions, the condensation reaction, will take place in the solvate shell of the molecules. What does this mean for the carbonyl group? We can assume that we will have some water molecules that can coordinate to the carbonyl group via hydrogen bridging bonds, but also such intermediary complexes, coordination complexes of the amine and water can also coordinate to that carbonyl group. And especially nice for the mechanism, I find, if you assume, well, we have that water coordinated to the carbonyl group, also here drawn, and then in addition an amine approaches, then you can have a hydrogen bridging bond between this oxygen and that hydrogen, between this oxygen and that oxygen, and now you can assume a six-member transition state with this nitrogen, that carbonyl, with this carbonyl carbon, that oxygen, that hydrogen, that oxygen and that hydrogen at the corners of the six-membered ring. Well, it attacks here as a nucleophile. The negative charge, the charge electron density, moves towards that hydrogen. Here this carbonyl double bond is broken to a carbon-oxygen single bond. Here, between this oxygen and the hydrogen, a bond is formed. This OH bond is broken. An OH bond is simultaneously formed here, and this nitrogen-hydrogen bond is broken. As a result, we are then here. Well, and this is the next intermediate you will have on the way to that imine. And this is a nice alternative as for formulating a mechanism, drawing a mechanism, compared to this concept where you have a zwitterionic intermediate and should deprotonate here and then protonate there. Thanks for listening.